Hello, everyone. Welcome to this information session for the Pitt Meadows Road and Rail Improvement Project. My name is Pam Ryan, and I will be assisting today as technical facilitator. Already, I'm having some challenges with the technical facilitation. It looks like folks are now joining us. Thank you for your patience and welcome again. I would like to acknowledge that I live and work in the traditional territory of the Musqueam, Squamish, and Tsleil-Waututh nations, and I'd also like to acknowledge that many of you are joining today from the territory of the Katzie, Kwantlen, and Coquitlam First Nations. Speaking on behalf of the project team, it is a pleasure to be here to provide important information about the rail noise and vibration component of the Pitt Meadows Road and Rail Improvement Project, and to facilitate answers to your questions. On that note, I would like to clarify that the focus of this session is the rail noise and vibration, including the studies and the results. Separate sessions were held last week for CP's rail scope, the rail configuration piece, and some of you may have participated in those sessions, and to you, welcome back. Very shortly, I will introduce my colleagues here from the Vancouver Fraser Port Authority, CP, and the City of Pitt Meadows, and then I will invite project leader Peter Cohen to offer a formal welcome and an overview presentation. Before I do, I would like to provide some important information about the format that we are using for today and to provide some technical information. First, I would like to point out that you joined in listen-only mode. We can change that when we get to the discussion portion of the session. And I know that I did see one hand raised. And like I said, we'll get to that when we get to the discussion portion. This format will ensure that we effectively deliver the information and the material that we need to deliver today, but also leave as much time as possible to answer your questions. Next, while you may be familiar with Zoom and some of its functions, for those who may be less familiar, I'll just do a very, very quick tutorial. For everyone's convenience, we are in listen-only mode, but your mute button, you will be able to control your audio when you're speaking, so you can use that to change your audio settings. Please submit your comments and questions using the question and answer function if you wish to do that in writing. So if you select the question and answer button on your Zoom screen, it'll open up a new window where you will be able to send your questions to the project team. If you are calling in by phone only, that is, you don't have access to a Zoom app, you can press *9 on your phone to raise your hand during one of the question periods that we will have this evening, and we will invite you to unmute yourself when it's your turn. We also invited written questions in advance. We did receive a few of those, and we'll deal with those written questions first at the appropriate time, and then we will address questions that come in through either the written questions in this webinar or for people who are raising their hands. There's a few sections within the presentation, and we'll pause. So we'll pause twice during the presentation and then once at the end to ask questions. We'll read the questions aloud and do our best to answer as many as possible in the time that's allotted. In the interest of time, we may group or summarize questions so that we can ask as many questions as possible. And any of the questions, whether they're answered tonight or if we have too many and we don't get to them all tonight, they'll all be part of the written question and answer summary that will be posted to the project website by May 4th. If you are experiencing any technical difficulties, please use the chat tool to liaise directly with us, and we'll do our best to troubleshoot. So chat is only for technical difficulties, please, and your questions go in the question and answer window so that we can deal with them in the order in which they are received. In the interests of encouraging open discussion, creating a safe space, and ensuring a constructive and positive experience, we ask that everyone remember the agreements that you made for today's session. Respectfully address ideas and concerns, understand the opinions, ideas, and feedback of others, and assume that each person is coming from a place of care for their community and or for the project. Encourage a safe space by welcoming curiosity, respectfully express disagreements without being disagreeable, and make use of the staff and technical experts that are here tonight to receive your ideas and feedback and to answer your questions. Finally, I note that this session is being recorded for note-taking purposes. Additionally, the presentation portion will be posted along with the written summary. In terms of our agenda for tonight, We will have a project overview, and then we'll stop very briefly for any questions of clarification about the project. Then we'll talk about how noise and vibration is measured and how it's regulated. We'll again pause for any clarifying questions on those items. And then we'll get to the noise and vibration studies for this project and the results, and then finish with quick next steps and move into the main question and answer portion for the session. I would now like to introduce the project representatives from Vancouver Fraser Port Authority, CP, and the City of Pitt Meadows, who are here to listen to you and to respond to your questions today. And I invite them to share their webcams as they do and just give a bit of a wave. First up, we have Peter Cohen, who is the Manager of Infrastructure Delivery. We also have Devin Fitch, Director of Infrastructure Delivery. Joelle Westland, Manager of Project Communications. And Deniva Pandey, Senior Communications Advisor for Projects. From CP, we have Mike Lavecchio, Director of Indigenous Relations and Government Affairs, and Jeffrey Knight, Director of Industrial Development. From the City of Pitt Meadows, we have Samantha Mackey, Director of Engineering and Operations, and Justin Hart, Project Manager, Major Projects. We also have Gary Mack from BKL, who is the noise consultant. And now it's my pleasure to pass the mic over to Peter Cohen to provide an official welcome and begin this evening's presentation. Peter, over to you.
Thanks, Pam. Good evening, everyone, and thanks for joining us this evening and for your patience as we got this underway. We know that many of you have an interest in learning more about the noise and vibration work we have done, and we hope that during this session, we can share with you more detail and can answer some of your questions. So as Pam just shared, for tonight, we will first start with some context of the project background. And then I'll follow this with a brief introduction to how noise and vibration is measured and regulated. And then I'll finish up by diving into the specific noise and vibration work we've completed to date on the project, which will round out the presentation. And we can then open up to a Q&A session for the rest of our time. So let's start with a bit of context as to our project background. Next slide, thanks. I'd like to start with an introduction of who is the Vancouver Fraser Port Authority and a quick snapshot of the Port of Vancouver. The Vancouver Fraser Port Authority is established under Transport Canada and is the federal agency responsible for the stewardship of the lands and waters that make up the Port of Vancouver, which is Canada's largest port. Trade through the Port of Vancouver connects Canadian businesses and consumers with the variety of products that we use every day from markets across the globe and generates tax revenues and secure employment for local communities. As a federal agency, the Vancouver Fraser Port Authority's mandate is to enable Canada's trade while ensuring safety, protecting the environment, and considering local communities. This mandate supports our national trade objectives for the benefit of all Canadians and ensuring Canada remains competitive on the global stage. Given the current pandemic and a need to rebound in the years to come, economic prosperity through trade is arguably more important than ever. To give you context to the Port of Vancouver that we oversee, it is the size of the next 5 largest Canadian ports combined. So if you combine the Port of Montreal, the Port of Saint John, the Port of Quebec, the Port of Sept-Îles, and the Port of Prince Rupert, these collectively would be about the same size as the Port of Vancouver. And when you compare to other ports based on tonnage, the Port of Vancouver is North America's 3rd largest port after South Louisiana and Houston. The port is the most diversified port in North America, which means we were able to handle a broad range of cargo, including bulk, which is like grain as it is loaded onto a ship loose, containers, break bulk, which is something that might be shipped on a pallet or within a drum, liquid bulk, again loaded directly onto a ship but in liquid form, automobiles, as well as we welcome the cruise sector. The port trades with 170 countries around the globe and is a critical gateway in connecting Canada to the world. Geographically, the Port of Vancouver includes more than 16,000 hectares of water, more than 1,500 hectares of land, and hundreds of kilometers of shoreline, bordering 16 municipalities and intersecting the traditional territories and treaty lands of several Coast Salish First Nations. And across Canada, direct employment supported by ongoing operations at the Port of Vancouver amount to more than 115,000 jobs across Canada, over 96,000 of these being in BC. Specifically in Pitt Meadows, port operations support around 700 jobs annually, which represents almost 4% of the city's population. Next slide, thanks. Building off that background of who we are and what we oversee, I'd like to transition into what we see for the future. The Port Authority, in consultation with regional partners through the Gateway Transportation Collaboration Forum, has analysed historic trade movement data and trends and engaged with the industry experts to assess the likely national and global market condition in the years ahead. With this information, we have identified a forecast of approximately 50% growth in trade volumes by the year 2030, as compared to volumes measured in 2015, and this is shown in the image on this slide. This 50% growth in trade corresponds to approximately the same year-on-year growth that has been observed in the last 5 to 10 years. And while subject to change as a result of items outside of our control, the COVID pandemic being a good example, we are still confident in this growth projection. But please keep in mind that it is possible that growth could be a bit slower, and these volumes reached a few years later than 2030, or that it could be faster and these volumes reached before 2030. Next slide, thanks. When you combine this trade growth with forecast population growth in the region, it highlights the critical importance of investing in infrastructure to ensure we can safely and efficiently manage this growth to both meet our trade objectives and also manage the impacts on local communities and our surrounding environment. As an example of our need to build capacity, if we look at just container trade for a moment, we know that this segment has grown in recent years and continues to grow globally. In Canada, we use containers to export a number of goods like grain and agricultural products, and then import using containers for things like consumer goods. Given this, we see that Canada's West Coast ports face a capacity crunch by the mid-2020s. And this is why the Port Authority is co-funding and delivering projects like the Centerm Expansion Project on Burrard Inlet to help keep up with creating capacity to meet this demand. We also permit all of the private development and investments on port lands to help facilitate this capacity growth. Projects like the Pitt Meadows Road and Rail Improvements Project are other ways in which the Port Authority is creating capacity in the gateway to Canada's largest port. And so all of this together indicates that the Port Authority plays a significant role in ensuring we, as a region, have the infrastructure in place to support trade growth. And this is all as part of our federal mandate to enable economic prosperity through trade for the benefit of all Canadians. I also wanted to take this opportunity to provide further clarity given some of the comments we have heard over the past couple of weeks from members of the community. This growth trend we forecast is not created by the Port Authority or CP. This growth is a representation of the health of a broader national economy, given Canada is a trading nation, and the ongoing growth in the Canadian products we export and the goods we import. So when you think of Canadian farmers in the prairies having a fantastic harvest year, needing to send their grain overseas, or that online purchase you made for a new desk to furnish your home office coming from another country, all of this feeds into the degree of trade movements that come through the Port of Vancouver. And we anticipate the steady recent growth we've experienced to continue in the decade ahead. Both the Port Authority and CP are federally mandated to simply enable these trade movements through the port and onto railway, and vice versa. And our responsibility is to ensure we have the infrastructure in place to ensure Canada can continue to grow as a global trading nation. Next slide, thanks. Based on this forecast growth in trade, we are prioritizing infrastructure investment in Pitt Meadows to help respond to the existing and growing impacts on these trade movements to your community. The Pitt Meadows Road and Rail Improvements Project received funding through the Government of Canada, Canadian Pacific, or CP, and the Port Authority to improve safety, efficiency, and capacity to move goods and people through the region and deliver significant national economic benefits and local community benefits. The Pitt Meadows Road and Rail Improvements Project is made up of 3 connected but discrete components. 2 of these are being led by the Port Authority and are shown in orange, the Harris Road Underpass and the Kennedy Road Overpass. The third component, led by CP, consists of 2 parts and is shown in red, and these are a new siding track as well as an extension of an existing lead track to the Vancouver Intermodal Facility. Some of you may be wondering, what could happen if the community doesn't support, say, the Harris Road Underpass? Does that mean the rail changes won't happen? And I'd like to provide you with some clarity. While the cliche of the whole is greater than the sum of the parts is certainly valid on this project, each component brings merits in its own right. Given the forecast significant trade growth, as well as CP's obligations To provide service and support of Canadian businesses and consumers while also operating in a safe and efficient manner, rail infrastructure investment along the Pitt Meadows corridor will likely happen in any future scenario. Given the proposed rail scope is wholly contained within CP's rail corridor, it is the Port Authority's understanding that CP can proceed with all, a portion, or a modified version of their component on their own. But it is also the Port Authority's assessment that the Pitt Meadows Road and Rail Improvements Project represents the most effective way to balance the interests of each partner and support a future which provides meaningful benefits to Canada, CP, and the Pitt Meadows community. Next slide, thanks. This image here illustrates all of the components together that create this Pitt Meadows Road and Rail Improvements Project. On the left side, shown in green, is the location of the proposed Kennedy Road overpass. Near the center, also shown in green, is the location of the proposed Harris Road underpass. Shown in blue, between Kennedy and Harris, is CP's proposed 10,000-foot siding track on the north side of the existing mainline tracks. And then shown in red is CP's proposed 6,000-foot extension to one of their lead tracks into their Vancouver intermodal facility. It's located on the north side of the existing mainline tracks and will extend the lead across Harris Road to roughly Golden Ears Way. All of these components have been incorporated into the noise and vibration study that we will be further discussing this evening. Just to also clarify in this image that where you see the existing main line shown in gray as a single line, this is just for illustrative purposes. As we all know, there are two mainline tracks through Pitt Meadows. Next slide, thanks. This slide hopefully provides you with one of the key benefits to the community that this project is bringing. Based on the forecast growth, one of the reasons why we are prioritizing this project is to help respond to the existing and growing impacts of these trade movements to the Pitt Meadows community. As you can see on this image, the existing delays experienced by commuters at Harris and Kennedy are shown in blue. And then our projections, shown in orange, indicate that by 2030, the delays at Harris will be roughly double what they are today and triple what they are today at Kennedy, in a scenario where the project is not constructed. Next slide, thanks. We also see many more excellent opportunities that this project can bring to the community. That includes improving things like public safety, emergency response times, reliability for commuters, pedestrian and cyclist connections, and public spaces, while also reducing things like congestion and emissions. My hope is that these last few slides help set some context of who we are as a Port Authority, what the project is, and some of the key benefits we see the project bringing to your community. So in 2019, the Port Authority retained BKL, an acoustical engineering firm, to undertake a noise and vibration assessment. The assessment measured current levels and modeled future levels with and without the Pitt Meadows Road and Rail Improvements Project. This assessment was completed in line with Health Canada guidelines for noise and guidelines for vibration from the US Federal Transit Administration, which I'll refer to as the US FTA. While we acknowledge it's currently noisy along the corridor, addressing pre-existing noise impacts caused by rail operations is not a core objective of the project. The focus of our project is to maximize our core objectives of ensuring the safe and efficient movement of people and goods by road and rail while identifying, analyzing, and mitigating impacts where warranted. This approach is in line with other transportation projects of this scale recently completed and currently underway in the Lower Mainland. The Port Authority will work with CP and the City of Pitt Meadows to explore opportunities to maximize the benefits of the proposed warranted mitigation to address any existing issues where we can. But I want to re-emphasize that this project does not have a core objective of addressing pre-existing noise impacts. However, that being said, as our subsequent slides will show, with the noise mitigation scope proposed to be incorporated into the project, we anticipate that conditions for some of the noise criteria we will be looking at will be improved in a 2030 scenario with the project as compared to today's conditions. Also, we will be sharing with you a proposed mitigation scope that not just responds to the minimum requirements identified, but goes above and beyond what industry guidelines recommend. Next slide, thanks. So the next couple of slides will give a brief snapshot of the technical lens as to how noise and vibration is measured. I will flag that I'm about to go into a bit of detail here, but I hope it gives a good introduction to what noise and vibration is for the purposes of what we are looking at for our assessment. Next slide, thanks. So noise is measured in decibels, and you may have seen this before shown as dB, but there is sometimes different versions of decibels used. A-weighted decibels, or dBA, is often used when describing sound level recommendations for healthy listening. While the dB scale is based only on sound intensity, the dBA scale is based on intensity as well as on how the human ear responds. Because of this, dBA gives us a better idea of how sound could impact your hearing. Decibels are different from other familiar scales of measurement. While many standard measuring devices, such as rulers, are linear, the decibel scale is logarithmic. This kind of scale better represents how changes in sound intensity actually feel to our ears. So I'll give you an example to better explain. Think of a sidewalk that is 80 meters long. If you extend the sidewalk by another 10 meters, so 12.5%, this would seem barely noticeable. This is a linear measurement. Using the logarithmic decibel scale, if a sound is 80 decibels and we add another 10 decibels, the sound will be 10 times more intense and will seem about twice as loud to our ears. So hopefully that gives you a sense of how the numbers used in decibels and the change in that number is a little bit different to other types of measurement, which you might be able to see from the examples using the scale indicated on this slide. The World Health Organization defines environmental noise as noise from all sources with the exception of workplace noise. That includes all unwanted sound or set of sounds that causes annoyance or can have a health impact. Environmental noise within the transportation category includes noise produced by road vehicles, ships, trains, and airplanes. Next slide, thanks. So now on to vibration. Next slide, thanks. By definition, vibration is the mechanical movement of an object about an equilibrium point. So kind of those green curves you can see on this graphic. The movements may be regular, such as a motion of a pendulum going back and forth, or more random, such as the movement of a tire on a gravel road, which is a little bit more sporadic. So when thinking about health effects of vibration, we measure the overall pressure waves generated by whatever is vibrating. It could be a piece of equipment or a structure. This is also known as vibration energy. Vibration has two measurable quantities. Firstly, how far the object moves. This is also known as amplitude or intensity. And secondly, how fast the object moves, also known as frequency. This helps to determine its vibrational characteristics. I recognize the past couple of slides have been a bit technical in nature, but we have more background information on how we measure noise and vibration in the materials that we have uploaded to our project website. Next slide, thanks. Building off on the background info, I'd now like to dive into the regulations and guidelines used in Canada when looking at noise and vibration on projects. Next slide, please. As the lead on the project, the Port Authority's role is to ensure that potential noise and vibration impacts caused by the Pitt Meadows Road and Rail Improvements project are identified and analysed by independent experts and to apply appropriate mitigation that is reflective of industry guidelines. Next slide, thanks. There are two important considerations to be mindful of when considering regulations and guidelines for noise and vibration. Firstly, the Canadian Transportation Agency, or CTA, sets the regulations for noise and vibration caused by rail operation and also manages complaints and resolutions. Secondly, Health Canada establishes the guidelines and criteria for noise caused by new infrastructure projects, similar to the Pitt Meadows Road and Rail Improvements project. And there are guidelines established by the US FTA as applicable to vibration considerations on new projects. The next few slides will go into a bit more detail of these regulations and criteria. One thing to note, though, is that we are providing this information for your awareness. If you had any specific queries or further clarification questions relating to these established regulations and guidelines, then they are best referred to that particular regulator. And we include these links in the materials we have uploaded to our project website. Next slide, thanks. Let's start with the CTA regulations, which sets the regulations for noise and vibration caused by rail operations and also manage complaints and resolutions. Section 95.1 of the Canadian Transportation Act states that a railway company shall cause only such noise and vibration as is deemed reasonable. The reasonableness takes into account sections 113 to 115 of the Act, which is often referred to as the Railway Common Carrier Obligations. This obligation is set by the Canadian Transportation Act and requires that railways must provide service, build infrastructure, and conduct operations in support of accommodating and delivering goods by rail to support the needs as requested of Canadian businesses and consumers. Next slide, thanks. In determining what is reasonable, the CTA will look at balancing the concerns of the communities with the need for a railway company to maintain efficient and economically viable railway operations on a case-by-case basis. The CTA has provided some information on their website as it relates to elements that they may consider in resolving any noise and vibration complaints with respect to reasonableness under Section 95.1 of the Canadian Transportation Act. Next slide, thanks. To add further clarity and guidance, the CTA's Railway Noise Measurement and Reporting Methodology document was developed as a reference guideline for railway companies, residents, and municipalities for how the agency may specifically consider certain situations. I would encourage anyone with an interest on this topic to visit the CTA's website, and we have the website identified at the bottom right of this slide. However, our focus for this evening's session is on the proposed Pitt Meadows Road and Rail Improvements Project, and I will now walk you through the Health Canada and US FTA guidelines that apply given this is a new infrastructure project. Next slide, thanks. With respect to noise considerations, Health Canada provides high-level guidance on identifying health risks related to noise anticipated from proposed major resource and infrastructure projects, again, similar to the Pitt Meadows Road and Rail Improvements Project. The guidelines provide an overview of how to assess potential health impacts with respect to a change in noise associated with the project, including noise that disturbs your sleep. We refer to this as noise-induced sleep disturbance. Noise that may interfere when you're talking to someone. We refer to this as speech interference, and noise conditions that are perceived as simply being very annoying. We refer to this as high annoyance. Health Canada does not have guidelines that relate to vibration, but per industry standards, we use guidelines from the US FTA to look at any changes in vibration levels from a proposed infrastructure project. Next slide, thanks. I recognize that this table has a lot of content, but this is a collation of all the criteria across the Health Canada and US FTA guidelines that we look at in terms of noise and vibration assessments on new infrastructure projects. I'm going to spend some time walking through this so you get an idea of the various things we look at. So looking at each one, on the first row, the speech interference criteria of 55 decibels represents the point at where background noise starts to impact sustained outdoor speech comprehension during the day. On the second row, the sleep disturbance nighttime criteria of 40 decibels represents the average outdoor noise level threshold to minimize disturbance to sustained sleeping. On the third row, the sleep disturbance maximum A-weighted criteria of 72 decibels references a World Health Organization recommendation that indoor noise levels when windows are closed should not exceed the 72 decibel value 10 to 15 times per night. On the fourth row, the high annoyance day-night criteria of 75 decibels is generally referenced to represent community noise levels and considers both daytime and nighttime noise levels, and takes into consideration the increased human sensitivity and annoyance from noise at night. On the fifth row, the high annoyance change of percentage high annoyance criteria of 6.5% looks at whether the percentage of people that are highly annoyed over a long duration is anticipated to change by more than 6.5%. 6.5% is identified as a percentage value that is deemed significant. This is the only noise measurement that is a comparative or percentage based, while the rest of them are absolute numbers. On the sixth row, the high annoyance low frequency criteria of 70 decibels looks at the annoyance from low frequency noise-induced rattling. For those with a keen eye, you will notice this decibel doesn't include the A at the end, and this is because it references noise-induced vibration. And lastly, the only vibration criteria we'll look at considers both frequent and occasional movements that pass by a household and is sensitive to how big of a difference in vibration levels one-off events might have when compared against more common events. Of importance for me to highlight is that the guidelines only recommend one criteria, and that's the high annoyance 75 decibel criteria that should apply mitigation. The guidelines do not indicate that mitigation should be applied to any other criteria. Where you see discuss severity as an action, this means that the project should look further into key considerations before making a determination. and looking at elements such as the number of households exceeding that criteria, to what degree, the extent of change, other community considerations, and overall affordability. This only needs to look at impacts created by the project. For where you see consider mitigation, this means the project may want to identify mitigation options and evaluate their acoustical effectiveness, practicality, feasibility, and cost. And for the action under the vibration, the project can determine and complete additional analysis as necessary. We have 3 defined objectives for the study. For the first objective, our study was to collect data that identified the existing rail noise and vibration conditions. This was for the Pitt Meadows rail corridor between Kennedy Road and Golden Ears Way. And this was done at select locations along the corridor where properties were likely to be most sensitive to noise and vibration. For our second objective, we needed to develop 3 models so that we can identify any potential implications of the project. The first model was to identify the existing conditions. The second model was to identify the future background conditions without the project, and we chose 2030 as this future year. And the third model was the future scenario with the infrastructure improvements proposed by the Pitt Meadows Road and Rail Improvements Project. And for our third objective, we used the established assessment criteria from Health Canada and the US FTA that we just walked you through to quantify the difference between the future 2030 scenario with and without the project. Any incremental difference that the project may bring in comparing these 2 scenarios in 2030 forms the basis for considering any potential mitigation as identified by the guidelines. Next slide, thanks. Here is some further detail of the scenarios that our study considered. On the left-hand side in orange is an overview of what were the inputs into the 2019 existing conditions. This scenario was modeled based on noise and vibration data that we collected along the rail corridor. In terms of rail movements, we identified roughly 27 to 28 freight trains per day, along with 10 weekday West Coast Express commuter services. In the middle, in gray, is an overview of the 2030 scenario without the project. This scenario is based on the Port Authority's look at the rail network across the region and the future rail modeling that we have undertaken. As shared before, this indicates that up to a doubling of freight train movements could occur along the rail corridor in Pitt Meadows based on the forecast growth in trade I walked you through at the start of this presentation. To be conservative, we had the assumption to just apply the doubling to the freight trains for the purposes of the scenario and the noise and vibration assessment, resulting in our model using the 56 to 59 freight trains per day in 2030. Note that this scenario assumes the same road and rail infrastructure that is in place today. So there is no Harris Underpass, no Kennedy Overpass, and no additional rail siding or lead extension as proposed by CP. On the right-hand side in red is an overview of the 2030 scenario with the project. It applies the same input information as the 2030 without project, but now also includes the Harris Road Underpass, the Kennedy Road Overpass, and CP's rail component that assumes a 10,000-foot siding track on the north side of the main line between Kennedy and Harris, and the 6,000-foot extension to the Vancouver Intermodal Lead on the north side of the main line that will extend over Harris Road towards Golden Ears Way. In other words, when considering the lead extension, this scenario looks at the rail operations described by CP in our 2 sessions last week and considers what difference having these rail operations occur 14 feet closer to residences on the north side and 14 feet further away from residences on the south side. Just as a reminder, per the Health Canada and US FTA guidelines, the purposes of our noise and vibration assessment in relation to the Pitt Meadows Road and Rail Improvements Project is to compare any incremental changes between the 2030 without project scenario, shown in the middle in gray, and the 2030 with project scenario, shown on the right in red. Existing and background rail growth is outside of what this project is responsible for resolving, as outlined in the regulations and guidelines sections we walked through a few slides ago. Next slide, thanks. Our study area and the scenario models for our noise and vibration assessment considers the rail corridor between Kennedy Road and Golden Ears Way. Between December 11 and 23 in 2019, prior to the COVID-19 pandemic, 6 noise monitors were placed along the rail corridor between Kennedy Road and Golden Ears Way. These 6 locations are representative of the locations within the community where the noise impacts could be the greatest. 4 of these 6 locations also collected vibration data. Health Canada does not discuss the number of monitoring locations required, but provides guidance on a number of approaches that can be used to estimate baseline noise. The methodology used for this study is reflective of best practice. During that time the data was collected, the monitors recorded data associated with rail and traffic movements 24 hours a day for 1 week. This map also includes a general illustration of any existing walls along the corridor, with the majority of these being around 2.4 meters high. Some of you may be wondering, for the 6 noise monitors we identify, how was it decided that these were the best locations to collect that data? And we can help provide clarity to this question. These monitoring locations were chosen to be at the residences that fronted the rail corridor and had clear line of sight to rail traffic. These locations are spread out along the corridor so that they can measure any difference in noise exposure at different segments along the corridor. This allows us to accurately calibrate our noise models for all households in our study area. You may also be wondering, why wasn't the study area expanded? And the reason for this is that we selected the study based on including land uses close to the rail corridor that could potentially have notable impacts based on the noise and vibration created by the Pitt Meadows Road and Rail Improvements Project. Given the suburban context of this rail corridor within Pitt Meadows, if you start to expand the study area further away from the rail corridor, we will start to notice interference between road-related noise caused from neighborhood streets and noise specifically attributed to rail. Next slide, thanks. So the study area included almost 600 households, and it included all residential buildings within 100 meters of the rail corridor, which is generally the first 2 rows of residences, and this is on both sides of the rail corridor. Towards Kennedy, we increased this distance to 350 meters from the rail corridor, as the closest households are a little further away. We also considered nearby schools and daycares, even if they were outside the 100-meter proximity. Commercial and industrial uses were excluded from this analysis. Where there are multi-dwelling properties, such as a multi-story residential building, each apartment or unit counted as 1 residence. So if a building had, say, 50 apartments, it was modeled as 50 residences or households in the assessment. When we use the term receiver, we mean the same as household or residence. We use all of these interchangeably, and they mean the same thing. It's essentially a location where, say, a family resides in a household and receives the noise. So receiver, household, and residence all mean the same thing in this assessment and in our presentation materials. In terms of how the model used the data collected by the 6 monitoring devices, the data we collected gives a strong representation of noise conditions along the rail corridor and allows us to build and calibrate a noise model. So if you look at the image at the top of this slide, it indicates the various receivers or households that were identified in the model, zoomed in at this specific location around Harris Road. And then the lower image gives you an idea of how the data we collected from our model creates a model for the full corridor. So whether we installed a monitoring device at your property, one of your neighbors, at a location several blocks away, or on your side of the tracks or the other side, if you live along the rail corridor within our study area, your property is still included in the assessment, and our team calibrates the model to ensure it gives an accurate representation of noise conditions along the corridor. And then in terms of the monitoring devices we put in place, these had a clear line of sight between the device, say a microphone, and the train traffic to collect the data. So whether there was an existing wall at the property, a chain link fence, or even a different height than what we've indicated for illustrative purposes, the data we collected is accurate, given the monitors were placed with clear sight lines of the tracks. For those curious, both of the images on this slide and a few others are included in section 8 of our baseline assessment report, and we have uploaded that document to our project website. Next slide, thanks. So in terms of the hierarchy for how we approached responding to potential impacts measured, we undertook the following in order. Firstly, we wanted to avoid or reduce the impact where possible. If you look at the noise and vibration baseline study that we have uploaded to our website, you will see reference to a consideration of a north-south option for CP scope. One of the factors why this option is not proposed to proceed and the north-north option proposed, which was outlined in CP's presentations last week, is that the anticipated noise and vibration impacts were expected to be more. And the option of the siding track and lead extension proposed by CP being on the north side of the main line actually reduces this impact and helps support this objective. The second consideration is that we mitigate where avoidance is not possible. And this is reflective in the upcoming slides as well, where we are identifying new noise walls or replacing existing walls with higher walls. And the third consideration is to take a broader consideration where mitigation is not possible or not fully effective. As we know that the grade separations, we are bringing significant community benefit in terms of improved safety, better reliability for communities and emergency services, and a more efficient movement of people and goods on your local roadways. Next slide, thanks. I'd like to now share with you our findings from the baseline study. Here is the data from the assessment we undertook that gives an overview of existing conditions. BKL's study confirmed what we have heard from the community, that existing conditions are noisy. As you can see from the data on this table, several Health Canada criteria are exceeded for a number of residences along the corridor within our study area. Next slide, thanks. So now looking forward to our future scenarios in 2030. With forecast trade growth, we anticipate that conditions may become noisier than they are today. Considering specifically the impacts of the Pitt Meadows Road and Rail Improvements Project in 2030, and separate from the projected trade growth, as we all know this might be happening regardless of the project is anticipated to increase these levels slightly. On the next slide, we again have more numbers to share, but before we get there, the right side of this image gives a good snapshot of what the key comparison between a 2030 scenario without the project and a 2030 scenario with the project means. So we see a 1 decibel increase at 35 properties along the rail corridor. We see a larger 2 decibel increase at 5 properties along the rail corridor. And as an average, we see an increase of 0.1 decibels for all properties within the study area as a result of this project. These numbers shared are the anticipated future levels, but an assumption of no mitigation being provided. However, this is not necessarily the case, as we will walk through shortly. Next slide, thanks. So before we look at mitigation, the next slide gives you an overview of the impacts that the project could bring if mitigation measures were not considered. Next slide, thanks. So on this slide, the colored sections of the chart highlight the categories that we are comparing to determine if mitigation is warranted, and if so, how much. The 2030 no project column in the middle identifies the number of properties forecast to exceed the criteria in the future without the Pitt Meadows Road and Rail Improvements Project. The 2030 with project column identifies the number of properties forecast to exceed the criteria with the Pitt Meadows Road and Rail Improvements Project. And as a reminder, any increase in the high annoyance category requires mitigation per Health Canada's guidelines. When you compare the difference in the high annoyance category between the two 2030 scenarios, you will see that as a result of the proposed project, 9 properties require mitigation. There is one household located near Harris Road that was identified as exceeding the criteria for vibration. Per the guideline recommendations, we will undertake further technical work to identify any potential feasible options. An example could be that it is resolved through further design refinement of the project. Next slide, thanks. Now I'd like to walk you through what we are considering for mitigation in response to what we have found. Next slide, thanks. So based on the results of the noise and vibration study and Health Canada's guidelines, 9 properties will require mitigation to reduce noise associated with the project to levels below the high annoyance criteria. That's the one I walked you through that establishes a threshold of 75 decibels and is indicated as LDN. The extent of mitigation that responds to this criteria is shown on this image in green. With this, the project is proposing to build approximately 245 meters of noise walls, 4 to 5 meters high, to meet those mitigation requirements. By applying this mitigation, these noise walls would also benefit 14 additional nearby properties. However, in addition to this minimum mitigation requirement as indicated by Health Canada's guidelines, the Port Authority is also proposing to go above and beyond the minimum warranted mitigation and construct an additional 365 meters of supplementary noise walls expected to be 2.5 meters high. This is illustrated in blue on this image. This additional supplementary mitigation is predicted to reduce noise levels for another 22 properties and will reduce noise levels on average by roughly 6 decibels at these properties. One thing I did want to flag while we're on this image is that we noticed a typo in the materials that we uploaded to the project website on April 19th that relates to this image. This image here is correct, and the materials in our project website have been updated to reflect this. Next slide, thanks. The chart here compares the number of properties that exceed the criteria in 2030 with 3 mitigation scenarios we have looked at to highlight the improved conditions with warranted and supplementary mitigation. The first column shaded in red, titled 2030 with project no mitigation, illustrates the results we presented in the table a couple of slides ago, and as the title suggests, takes into consideration of the impacts of the Pitt Meadows Road and Rail Improvements project, but no mitigation measures are applied. The second column, shaded in red, titled 2030 with project warranted mitigation, illustrates the results of the assessment with the warranted mitigation included as part of the project. In other words, that's the scenario where we just include the 4 to 5 meter high walls shown in green on the last slide. As you can see, the number of properties that exceed the noise level criteria if the project is constructed with this warranted noise mitigation is lower in 4 of the 5 applicable criteria, and the same for the final 5th criteria as compared to the 2030 no project scenario. This equal or better comparison is represented by the check marks. Just to re-emphasize, this is the necessary mitigation that the Pitt Meadows Road and Rail Improvements project needs to provide in responding to the Health Canada guidelines. However, as shared on the previous slide, and in consideration of the importance to the community of addressing noise and vibration, the Port Authority is also proposing additional supplementary mitigation to further improve the conditions along the rail corridor. This is above and beyond what is recommended by Health Canada and was represented in blue on the previous slide. As you will see in the last column of this table, titled 2030 with project warranted and supplementary mitigation, this additional 365 meter section of wall that we propose further improves the speech interference category and portions of the sleep disturbance and high annoyance categories. Just while I'm on this slide as well, I also want to point out there is a tick missing on the sleep disturbance row, and that should be included to represent that we are meeting all the Health Canada guidelines. Next slide, thanks. With the inclusion of supplementary mitigation scope over and above the warranted mitigation scope, we move away from simply mitigating the noise and vibration impacts of the project and towards enhancing the experience for the local community with respect to current conditions. Take, for example, the sleep disturbance criteria, the third row of the table indicated by LF max. Today, there are 397 households that exceed the 72 decibel criteria. With our proposed noise and vibration mitigation and enhancement scope, this number will be reduced to 375, so 22 fewer than there are today. And then for the high annoyance category, the 6th row of the table indicated by LLF, today there are 117 households that exceed the 70 decibel criteria. And with our proposed noise and vibration mitigation and the enhancement scope, this number will be reduced to 97, so 20 fewer than there are today. I hope that this demonstrates to you that our combined warranted and supplementary noise mitigation scope that we propose on the Pitt Meadows Road and Rail Improvements project not only meets, but also exceeds the guidelines that are established by Health Canada. Next slide, thanks. So now to a quick look at next steps. Next slide. Over the next few months, the Port Authority will work with the City of Pitt Meadows and CP to further refine the noise mitigation scope that will meaningfully respond to future noise impacts associated with the Pitt Meadows Road and Rail Improvements project, while mitigating the impact of properties. We will work further on details such as materials, aesthetics, and exact locations of the noise walls, and have more detailed discussions with directly impacted property owners. We will also share further updates on the noise mitigation scope with the community in future project updates. Thank you for your time while I've walked you through quite a lot of content, some of it being quite technical in nature. But before I finish up and pass back to you, Pam, and open up to questions, I did want to respond to a couple of questions that we have heard from the community to provide some clarity. So the first question revolves around why more isn't being done, given the feedback we received that the community is experiencing the entire corridor being noisy. So in terms of an answer to that, there are many factors we've considered when determining the locations for noise mitigation. For the warranted mitigation, it was based on what our assessment identified in applying the Health Canada guidelines. But for the additional supplementary mitigation over and above what is required by the Health Canada guidelines, we looked at what would bring the most meaningful solution when considering the additional cost and what benefit would be received. Similar to other projects, we have to balance competing priorities against project partner objectives and affordability. Our goal on the Pitt Meadows Road and Rail Improvements project is to enable the safe and efficient movement of goods while reducing the impact to the community through improved safety, better access, and reduced wait times. We believe that the mitigation scope we have shared with you this evening demonstrates that we are not just meeting what industry standard processes are telling us, but that we are also exceeding these to bring more enhancement to the community where we can in balancing various project priorities. And then the second question relates to how we've illustrated the existing walls on our maps. So for our baseline assessment, we relied on aerial imagery and general site observations to provide an indication of the existing walls along the rail corridor. We consider this to be industry standard practice, where on-site access may be difficult, such as requiring permissions from hundreds of residents, where there may be safety risks, such as large moving trains nearby, or where we are simply trying to reduce exposure of the project team, such as during a pandemic. We have shared the full noise and vibration assessment report on our project website, which includes the assumptions we used, which provides the community with the opportunity to review our methodology and assumptions. If you think we got something wrong relative to existing conditions, let us know, and we will review on a case-by-case basis. If we have inadvertently incorporated an incorrect assumption, and we will have our consultants correct this, update the analysis, and share accordingly with the community.
This is all the time that we have for today. I just want to thank everyone for taking the time. And we trust that this has been useful. I hope we've answered some new questions. I know some people have joined us for all 4 sessions. Some people signed up for just one. So thank you everyone for the time that you have spent with us over the last 2 weeks. As I mentioned, questions that we're unable to answer today will be included along with the answers in a session summary that will be available on the project webpage by May the 4th. Thank you so much for your time. Please do visit the project website. Please, we do welcome any follow-up questions as well as feedback on your experience in today's session on behalf of the project team. Thank you. We are finished and have a wonderful evening.